All right, so now we're diving into exponential equations. So my first problem, I've got 5 raised to the x power minus 1 is 25. Okay, so if you can make your bases match, it just saves you from having to go into log world. Okay, if you can make your bases match. So can I write 25 as a power on 5? I can, because 25 is 5 squared. So I've got 5 raised to the x minus 1 equals 5 squared. So since our mission is to get the left side equal to the right side, the bases are done. Okay, bases are done. So just grab your exponents and deal with them. And now solve for x, and we have x equals 3. So that should make sense, because 3 minus 1 is 2, and 5 squared is 25. Okay, so we have, hang on, looking for the next one. All right, do it again. So this one is not going to be as straightforward as the last one, because I cannot make my bases match. I cannot make my bases match. So you could still use this same procedure on this one if you didn't realize that you could have made the bases match. So both sides are as simple as possible. I'm going to take, remember, I need to solve for x. That x is trapped up in the exponent, so I've got to be able to reach him, so I need to go to log world. Okay, so I'm going to take the log of both sides. You can use common log or natural log. I don't care. Why did we go to log world? Because now I can grab that exponent and drop it out front as a coefficient. So remember to do that in parentheses, because that exponent belongs to the entire thing. Okay, so now what I have, remember the natural log of 18 is a number. Okay, so this number times both of those, well, it's connected with multiplication. So I can divide both sides by this number. So any number divided by itself is 1. That leaves me with a 3 minus x is the natural log of 30 over the natural log of 18. So again, I'm trying to solve for x. So I'm going to subtract 3 from both sides, which gives me a negative x equals a negative natural, equals a natural log of 30 over a natural log of 18 minus 3. Okay. So now what we want to do, I don't care what negative x is, I care what positive x is. So I've got this chunk equals this chunk minus this chunk. I'm going to divide by -1 and change all the signs. So that becomes a positive x equals a negative. So this is just a fraction. Okay, so don't change everything. And then a positive 3. Okay, so now what do I do from there? What I do from there is I slap this whole thing in my calculator. So I'm going to do negative natural log of 30. So negative natural log of 30. Okay, find out what that answer is. Divide that by the natural log of 18. And find out what that answer is. And then add 3. Whoops. Plus 2 is 3. All right. So I've got a 1.8233. 1.8233. So 1.8233 is my answer. So minimize. 1.8233. There you go. Right there. All right, so let's do it again. So these are all called exponential equations. Exponential equations. So what I have here is 3 times e, which remember is a number, to the 8x plus 4 is 7. Now what's the issue? The exponent contains my variable, but it's only attached to e, which means that 3 is in my way. Okay, so I don't want to go to log world until I get rid of that 3. So I'm going to divide both sides by 3. So he's gone. And I have e to the 8x plus 4 is 7/3. All right, so normally we say we don't give a rip which log you use. But since the base of a natural log is e, and I have an e sitting here, it's going to help me be lazy if I use natural logs. So on the last one, I really didn't care. You could use natural log or common log. I really want to use natural log on this one. So I'm going to take the natural log of both sides, and that allows me to grab this exponent and drop it out front as a coefficient. So I've got 8x plus 4 times the natural log of e equals the natural log of 7/3. Now here's the cool part. What's the natural log of e? Remember, your base is e, your argument is e, and if your base and your argument match, it simplifies to 1. Okay, so the natural log of e equals 1. So 1 times anything isn't going to change what it is. So I can rewrite this thing without the natural log of e. And I should probably be putting those in parentheses. All right, so I'm going to subtract 4 because I'm trying to solve for x. So 8x equals the natural log of 7/3 minus 4. And now I'm going to divide everything by 8. So I get x equals the natural log of 7/3 minus 4, all of that over 8. Okay, so in my calculator, first thing I'm going to do is the natural log of 7/3. Natural log of 7/3. Find out what that is. Then I'm going to subtract 4 from that. And then I'm going to divide that by 8. So I get negative 0.3941. Negative 0.3941. So when I come back here, I get negative 0.3941. Is going to be your answer right there. Okay? Here we go. All right, so solve the giving logarithmic equation. The given, not giving. So I have the log base 2 of x equals 3. So what were our three formats? Our three formats, excuse me, was exponential equals exponential, a single log equal to something else, or a log equal to a log. So this is a single log equal to something else. So our strategy is to convert back to exponential. So this is your base. So 2 raised to the 3rd power equals x. Well, I happen to know what 2 to the 3rd is. 2 to the 3rd is 2 times 2 times 2, which is 8. Okay, so 8 equals x. You started in log world, so you better check your answer. So substitute back in. Is 8 positive? Yes. Is 8 not 0? Correct. So I'm allowed to use 8. So 8 is your answer. Okay, so 8 is your answer. All right, log base 6 of 5x minus 1 equals 4. So again, what are our three scenarios? Exponential equal to exponential, single log equals to something else, or log equals log. Well, this is single log equal to something else. So we're going to go ahead and we're going to change it to exponential. So what I have is 6. My base is 6. I'm raising it to the 4th power, and that's going to equal 5x minus 1. So now I'm solving for x. Well, I need to know what 6 times 6 times 6 times 6 is. So 6 raised to the 4th power, 6 raised to the 4th, is 1296. Okay, so I have 1296 equals 5x minus 1, and now I'm trying to get x by itself. So I'm going to add 1 to both sides. Add 1, and I get 1297 is 5x. And now I'm going to divide both sides by 5. And that is not going to break down. Okay, so your answer is 1297 over 5. Okay, so make sure you check your work. 5 times 1297 over 5, the 5s will reduce. So that'll give you 1297 minus 1 is 1296. Okay, that's positive and not 0, so it works. So I'm allowed to use that answer. All right, minimize. Blink. All right, 20 gajillion logs. So we have log 5x equals log 3 plus log x minus 5. So what's our scenario? Exponential equals to exponential. or a single log equal to something else, or logs equal to logs. So I've got logs on both sides. First step is you better make sure you have one log equal to one log. So I need to condense these. If it's addition on the outside, it's multiplication on the inside. So now I've got the log of 5x equals the log of this argument times that argument. So 3 times x minus 5. And by the way, you started in log world, so you better check your answer. All right, what base am I in? My base isn't written. If it's not written, it's either base 10 or it's base e. So this is a common log, so we're in base 10, just to call that to your attention. All right, so if I'm trying to get things equal, I've already got the log of both sides, so now I just got to concentrate on the arguments. So I'm going to grab the arguments and set them equal. Okay, so I went ahead and distributed that 3. So 3 times x is 3x minus 15. And now I'm going to solve for x. Okay, so I'm going to move my smaller x's. So I get 2 x's is negative 15. Okay, divide both sides by 2. So I get x equals negative 15 halves, which is the same thing as negative 7.5. Okay, so check your answer. So what is 5 times negative 15 halves? Well, a positive times a negative is negative. So you just blew the whole thing out of the water. So we stop. This is impossible. There is no solution. You did your math right, but the answer is not usable, so that's extraneous. Okay, so you have no solution for this. So when I look at my options, I got no solution. The empty set. Okay, let's try another one. All right, so I've got logs equal to logs. So I've got log 4 plus x equals, no, minus, that's minus. All right, log x minus 2 equals log 5. Okay, so first question is, what base am I in? I'm in base 10. Okay, that might come in handy later, probably won't. All right, so that's supposed to be subtraction. I put equals by accident. All right, so my format is logs equal to logs, but I need a single log. So I need to condense. If it's subtraction on the outside, it's division on the inside. So I'm going to have a single log of 4 plus x over x minus 2. And that's going to equal log 5. So now that I've got logs equal to logs, I'm just going to grab the arguments and mess with them. So, oh, you better check your answer, okay? I keep forgetting my pink star. All right. So I've got a 4 plus x over x minus 2 needs to equal 5. That 4 plus x is irritating me. It should be x plus 4. All right, so I'm going to cross multiply. This is a proportion. So I have x plus 4, all I did was flip it, equals 5 times x minus 2. Okay, so now I've got x plus 4 equals 5x minus 10. I'm going to move my smaller x's, so I get 4 equals 4x minus 10. I'm going to add 10. So I get 14 equals 4x. I'm going to divide both sides by 4. So I get 7 halves equals x, which is roughly 3.5. So check your work. 4 plus 3.5 is positive, okay, and not 0. 3.5 minus 2 is positive and not 0. And there's nothing to evaluate on the right. So our answer does not cause the world to explode. So you have a single answer of 7 halves. Okay, single answer of 7 halves. And, okay, I'm going to stop here.